Today is going to be very short because we are just doing an extension of multiplying radicals with a 2x2 type situation. So we're going to go over distribution first and then box method second. So make sure you do both, but remember on tests and quizzes you can use whichever one you would like. So one thing we have to make sure we're very certain of is how many terms that we have. This is a 2x2 right here, but one thing that can get confusing is this first term. Because you see two numbers, a lot of times students will think that this is two different things, but this is just one radical. This is the outside, this is the inside. So just like with distribution before, we're going to break apart the first one, so -2 root 2 and a positive root 3. And we want to distribute both of these to the second polynomial, but that gets a little confusing with our arrows. So we break it apart and we're going to stick the second one behind it so it looks just like a normal distribution problem. It's a little bit easier to manage. Okay, so now that I have my two problems set up, I'm going to distribute. So remember, this is an outside -2. If we don't see an outside, that is always the number 1. So -2 times 1 is -2. Inside times inside is going to give me 4. -2 times -1 is +2. 2 times 3 on the inside gives me 6. So that's the first one, and then now I do the second one. So I distribute here, outside with outside stays a +1, inside with inside, root 6. Outside with outside, remember that's -1 here, so -1 root 9. Do now is look to simplify and combine like terms. I'm going to kind of go through and look at what I have. So I have a root 4, which can break into a 2 and 2. I'm going to combine my pairs, right? And that's going to come outside. Now, if you notice, there are no singles, which means my radical will disappear. So I get a -4 because 2 times -2. Here, remember, 6 does not simplify, but go ahead and just double check anyway whenever you have a number. Don't assume, double check it. So these don't simplify, but one thing we can notice is that these are actually like terms. So what I can do is combine them. So remember, combining like terms, you just add the coefficient. So I have +3 root 6. And then root 9, I look to simplify. This breaks into 3 and 3. This is a perfect square. 3 times -1 is -3. Now, careful. This is not your final answer, because if you look, I had two perfect squares, which means now I have two constants that can be added together. -4 and -3 is going to equal -7. So this becomes 3 root 6 minus 7, and that is our final answer. So when we have these bigger multiplication problems, oftentimes you'll have like terms revealed later and you'll have to combine again for a second time. So we combined here and then we had to combine again after simplifying. Okay, so same thing. Break apart the first one. So -4 root 5. Stick the second behind. So 4 plus root 5. 4 plus root 5. Distribute. -4 times 4 is -16. Remember, this is an outside. If you don't see a radical, it is the outside. So I'm going to get -4 root 5. And then I distribute again. So root 4, or +4 root 5. And then outside with outside is a 1. Inside with inside, 5 times 5 gives me 25. So this can't be simplified, right? This is a whole number. These two can combine, so I'm going to rewrite this. -16 comes down. I have -4 and +4, so that actually makes 0, so it cancels. And then if I look, 25 breaks into 5 and 5. I have a pair that comes out. 5 times 1 is 5, so this just stays 5. So if I look in this one, this is all I'm left with right here, -16 and 5. I can combine these two, and that is going to leave me with -11, and that is my final answer. So this simplified to a complete whole number. Okay, try number 3 on your own. Pause the video, try it on your own, and then check. Okay, so we separate here. We have a root 3 and a 2 root 5. And then behind both of those, I'm putting the second polynomial for distribution. So I distribute the first. Outside, remember, if you don't see it, it's a 1. So if you like to pencil that in, you can. 1 times negative 1 is negative 1, and we get root 9, the 3 times 3. 1 times 1 is 1, and then 3 times 5 is going to give me a root 15. Distribute the second one. 2 times negative 1 is negative 2. 5 times 3 gives me root 15. 2 times 1 is 2. 5 times 5 gives me 25. So root 9, that will simplify 3 and 3. That is a perfect square. You should see a trend that we do get a lot of perfect squares when we multiply. So I get a negative 3. 15 breaks into 3 and 5, so this does not simplify, but I can combine right here. I have a positive 1 and a negative 2, so I have a negative 1, root 15. And then 25 will break into 5 and 5. So another perfect square. Remember to multiply to the front number. 5 times 2 is a 10. Now, always double check if you have more like terms after simplifying. So here we actually do. We have a negative 3 and a positive 10. So those two will combine, and we end up with negative 1 root 15 plus 7. Leave number 4 for class, and we will look at box method. All right. So, like I said before, be very careful about counting how many terms you have. This negative 3 root 3 is one term, right? One radical, so one term. This is my second term. This is one term. This is the second term. So this is a 2 by 2, which is what kind of box we will draw. And then remember, it does not matter which polynomial goes where. It just has to stay together. So we label, and then this shows us all the pathways of multiplication. So negative 3 times negative 4 is 12, so 12 root 9. Negative 2 and negative 3 makes positive 6 root 3. Negative 4 makes positive 16 root 3. Negative 2, negative 4 makes positive 8. Now, just like before, you can see when you have like terms. So if you look here in the diagonals, we have root 3. So when we pull this all out into one line, you can go ahead and combine that as you bring it out. So I'm going to start off with 12 root 9, and then the root 3's will combine. So 16 and 6 makes 22 root 3, and then the 8 comes out. Now, I do need to look to simplify. So 9 breaks into 3 and 3, so perfect square. 3 and 12 makes 36. So I'm going to bring everything else down. And we should see that because we simplified and had a perfect square, we now have like terms. So 36 and 8, that is going to combine. So I get 22 root 3, that comes down. And then we have plus 44 is what it combines with. So that is our answer. So again, making sure we understand this is 1 and 2, 1 and 2. So it is a 2 by 2 box. Draw it big because radicals can be kind of big numbers. So make sure you leave yourself enough room, and then we label. So remember, if you don't see a coefficient, it is 1. So you can pencil that in if you need to. So this is going to give me a positive 1 root 8, positive 1 root 6, negative 5 root 12, negative 5 root 9. So what we see here is there are no like terms, but some of these will be able to be simplified, so we'll just see what happens. So I'm going to pull everything out. And simplify. 8 breaks into 2 and 4, 2 and 2, so this does simplify. The 2 comes out, so 2 times 1 is 2, root 2. 6 breaks into 2 and 3. There's nothing to pull out, so it stays root 6. 12 breaks into 2 and 6, 2 and 3. The 2's come out, so negative 10 times 2 is negative 10. Our single 3 goes back in. 9 breaks into 3 and 3. The pair comes out, so 3 times negative 5, negative 15, and then there's no radical because there's no inside. So by simplifying, we still see we don't have any like terms. Okay, so that's fine. This is just our final answer. Okay, Try number 7 on your own. Pause the video, try it on your own with box method, and then see how you do. Okay, so 2 by 2. So remember, just because there's a coefficient, that doesn't mean it is another term on its own. This is one term, this is 1. 1, 1. So 2 by 2. Coefficient in front is 1 if we don't see it. So 1 times 3 gives me 3. Insides, 2 times 2 gives us 4. Outsides, 3 times negative 2 is negative 6. Insides, 2 times 3 is 6. Outside gives us negative 2. Inside gives us 6. Outside gives us positive 4, right? Negative times a negative. And then inside gives us 9. So you can see here in this one, we do have like terms right here, the root 6's. So when I pull everything out, go ahead and combine. So negative 2 and negative 6 becomes a bigger negative. So it's negative 8 root 6 and plus the 4 root 9. So 4 breaks into 2 and 2, perfect square. So that makes 6. We know that 6 does not break apart, so we bring down the negative 8 root 6. 9 breaks into 3 and 3, so the 3's come out, leaving us with a perfect square again. And we see again, we have some like terms revealed after simplifying, so we got to combine those again. So last thing, we end up with negative 8 root 6 plus 18, and that is our final answer. Leave number 8 for class, and that is it. So just working on 2 by 2 multiplication.